So in this example, you've been told to use the binomial theorem to determine the first three terms of the expansion 25 minus x all raised to power half. Hence, use the expansion to calculate the value of square root of 24. To how many decimal places?
3.
To 3 decimal places. Are we together?
Yes.
So for you to use a binomial theorem, you know when you have 25 minus x raised to power half, this is in this form. It is in the form 25 minus x is in which form? So it is in the form of a plus x raised to power n, isn't it?
Yes.
So we start, when you have a plus x raised to power n, the first term is 0 factorial, isn't it?
Yes.
So remember, when you have n factorial, it is supposed to be n into n minus 1 into n minus 2 into n minus 3 in that order, isn't it?
Yes.
So when you have 0 factorial, it means there's no term in the numerator, isn't it?
Yes.
And x is raised to power?
0.
Power that 0, isn't it? So if x is raised to power 0, it means a is raised to power n minus,
0.
because our term there is n, isn't it? It means a is raised to power n minus 0. Are we together? Then the next you go, after 0 factorial, you go to 1. When you have 1 factorial, it means you only have one term in the numerator. And one term in the numerator is what? N. Then our x is raised to power 1, isn't it? So if x is raised to power 1, it means a is n minus
1.
Are we together? You were told the first three terms, meaning this is the first term, second term, then you look for the third term, isn't it? Are we together? So the third term will be, if this is 0 factorial, 1 factorial, meaning the third term is 2. So 2 factorial means you have how many terms in the numerator? See, 2 factorial means 2 terms in the numerator.
Yes.
So it is n and n minus. So here we have n and n minus 1. Those are 2 terms, isn't it?
Yes.
So our x is raised to power 2. Then our a is going to be raised to power n minus. Are we together?
Yes.
So I need space there. Maybe I can squeeze this. This is n over 1 factorial x raised to power 1, a raised to power n minus 1, isn't it? Then the next one, when you have 2 factorial, it means we have 2 terms in the numerator, n and n minus 1, isn't it? So here we have n and n minus 1. Then your x is raised to power this 2, isn't it? X is raised to power 2, meaning a is now going to be n minus 2. Are we together? Now after that, you now bring back your original equation. Your equation, the equation you've been given is 25 minus x raised to power a half. So if this is x and this is also x, meaning you can let this one to now to be x1 to make them distinct, to differentiate them, isn't it? So you can now see in this our equation, the position of a is occupied by 25, meaning a is equals to 25. Are you seeing? In this our equation, you can see the position of n is occupied by a half, meaning n is equals to a half. In this our equation, you can see x1 is the same as negative, meaning the position where x1 is occupying, negative x is occupying, because it's supposed to be plus, isn't it? So it means here it is plus negative x, meaning our x1 is negative.
X.
So it means what we do in this formula, we just substitute. Now if you look at this formula, 0 factorial is 1, anything raised to power 0 is 1. So it means the whole of this term will simply, then n minus 0 is just n. So here 1 times a raised to power n, meaning this first term will just remain with a raised to power n, isn't it? Are we together?
Yes.
If you simplify, isn't it? So can we now start substituting? The first one is a raised to power n, meaning it is 25 raised to power half. A is 25, n is a half. 25 raised to power half, isn't it?
Yes.
Are we together?
Yes.
Go to the next term. We have plus n is a half, over 1 factorial. Then our x1 is what? x1 is?
Negative.
Negative x. So you have to put it in bracket, isn't it?
Yes.
So x1 is raised to power 1. Then your a is what? 25, n minus 1. What is your n? Your n is a half, isn't it?
Yes.
So it is now a half minus 1.
Yes.
So a half minus 1 is negative. You are done with that, isn't it? Go on, it is plus here n is a half, then n minus 1. A half minus 1, you get negative a half, isn't it? Over your 2 factorial, isn't it? Then we have x1 squared. What is your x1? Your x1 is negative x. While there is x1, you put negative x, then it is squared, isn't it?
Yes.
Then your a is 20. See, your a is 25.
Yes.
Then it is raised to power n minus 2, a half minus 2, isn't it?
Yes.
Because n is a half. So a half minus 2 is negative. See, negative 3 over 2. Are we together? Are we together? So start, go to the calculator. What is 25 raised to power half? See, it is 5.
Yes.
Meaning square root of 25, isn't it? Yes. Go here, simplify this. A half divided by 1 factor is just a half. We are simplifying, okay? Are we together?
Yes.
So it is plus negative raised to power 1. See, that is negative. Go to the calculator. What is 25 raised to negative a half? See, it is 1 over 5. Because negative means reciprocal. If you have 25 raised to negative a half, it means it is 1 over 25 raised to power half. That negative implies reciprocal. 25 raised to power half is square root of 25, which is 5. So you get 1 over 5.
Yes.
Good. So this is a half times negative 1. You get negative a half times 1 over 5. So you get negative 1 over 10.
Yes.
Are we together?
Yes.
So you get there negative 1 over 10. Then your x is also raised to power 1. You've simplified the whole of that, isn't it? Move to the next term before you put the sign. It is a half times negative a half is negative 1 over 4, isn't it? Then you move again. Negative squared is positive, isn't it? Then x squared is x squared. You simplify that. Then this one is over 2 factorial here, isn't it? Then there 25 raised to negative 3 over 2. Go to the calculator. What is 25 raised to negative 3 over 2? I can see it is 1 over 125. What do you have? 25 raised to negative 3 over 2. Because that is 1 over 25 raised to 3 over 2. See there? So 5 cubes. See, that is 1 over 125.
Yes.
1 over 125. So if you work out all this, so go to the calculator. Negative 1 over 4 divided by 2 factorial. 2 factorial is just 2, isn't it?
Yes.
So negative 1 over 4 divided by 2. So you get negative 1 over 8.
Yes.
Negative 1 over 8 times 1 over 125. See, you get out negative 1 over 1000. Then your x is squared. Or do you have a different thing there?
Negative 1 over.
Yes, negative 1 over. Some of these things you just look at them and you see, isn't it? So you can see an expansion of 25 minus x raised to power half is 5 minus 1 over 10x minus 1 over 1000 x squared, isn't it? So after getting this expansion, this is the expansion of 25 minus x raised to power a half. You've been told to use it to solve the square root of 24. So for you to get the square root of 24, it means you are comparing them. Are you seeing that? Yes. So you have 25 minus x raised to power half is equals to 24 raised to power half. Because square root of 24 means 24 raised to power half, isn't it? Yes. So it means if you square both sides of the equation, you will get rid of this power half, isn't it? Yes. So if you get rid of that power half, you remain with the 25 minus x to be equals to 20, isn't it? So if you take x the other side of the equation, you bring 24 this side of the equation, you will get x to be equals to what? To be equals to 1. Meaning, for this equation to be equals to 24 raised to power half, the square root of 24 raised to power half, it means where there is x, you put
1.
Where there is x, you put 1. So that equation we had, that expansion we had 5 minus 1 over 10x minus 1 over 1000 x squared. Because when we compare root 24 and this root, we found that 24 raised to power half will only be the same as 25 minus x raised to power half. They will only be equal if x is 1. Are you seeing that? Yes. So when you put x to be 1, it means you are looking for the square root of 24. Are we together? So what do you get? If you put x to be 1, what do you get? You get the answer to be 4 point. Because this is 0.1, this is 0.001. Yes, 4.899. And that is the square root of 24. Are we together?
Yes.
2 3 decimal places you were told, isn't it? Okay? Yes. That is how to use a binomial expansion to sort out any problem. Okay? Good.